Okay, my watch says it's time to start, but I'm not 100% convinced about that. But never mind that. Okay, so a couple of things. You're not many, but never mind that. The very first thing, my assistant Justin will now demonstrate that you can access your marks. Justin, please, the floor is, just log in. Oh, you've logged in before?
Yes, I have.
I see. We didn't prepare this at all. Thank you, Justin. Your work here is done. That's enough.
What?
Oh, no. Oh,
Yeah.
oh man. You work with amateurs. Have you never been on stage before? Have you not performed?
Yeah.
Thank you. Thank you so much. All right. Okay. Now, Justin has just logged in. Thanks. I was saying Justin has just logged in. And apparently he's now on sun.learn. No, he's not. We're now at my.sun. So where did you go, Justin?
Studies.
Studies, yes.
Yeah, right at the bottom of that, there should be the next tab. Arrow on the side.
Oh man. Early assessment marks. Oh. Oh. Well, no. Well, it's on there. Okay, but let's just ignore that. I don't want to show Justin's marks for all his others. So what I really wanted to show you was, just in case it didn't load up on the system, which I didn't know that it did. I don't have marks of my own, and I can't manage this complex system. I never go to sun.learn, my.sun, it's too complicated. But on sun.learn, I put the marks up as well. So if you go to grades, am I now Justin? Yes, I am. Grades. It should say that Justin scored 53555. Okay, so just 23 out of 25. So Justin's marks and all your marks are up if you wrote the written test. The written test, Justin, don't get excited. This is merely the written test. So the marks are, I'll put them on sun.learn, even though I've been tested, it takes hours because it's really slow. It is convenient, at least. So you can access those. I'm sorry I didn't do this earlier. I just assumed that'd be on the system, whatever that means. Now, next, practical test. How did it go? What's your name? Brooklyn?
Richard.
I think I'll call you Brooklyn. I like calling people by their initials. So, Brooklyn, how did the practical test go?
It was okay. Yeah.
Oh, you sound, that's so convincing.
Well, it wasn't that bad.
Easy, one and so.
Not particularly easy, but I got all the core.
So what was that? What's your surname, Brooklyn?
Louise.
Louise. Oh, that's interesting. Sorry. So it's not Louis.
No.
Louis. That's Louis. Got it. Oh, Louise, like in Spanish. Hablas español. Portuguese. Okay, excellent. Okay, now, L, so you wrote the second one. So what were the problems? What did? No, I mean, what were the questions? What was the first one? Oh, little calculator. Why is there an odd light flashing? Yeah. The little calculator, that was easy peasy, wasn't it? And then the second was, what was that? Oh, 3 sums. Okay. Oh, that was not hard. Small arrays. And the last one was coiner. So if you wrote the second test, those were your 3 problems. Who wrote the first? Justin. Your surname is Stickling. Is that also Portuguese? Oh, German. Ach so. I don't really speak German. Begin met zo'n Schweizerdeutsch, maar geen Duits. Do you, what prompts did you get? Okay, so that's almost the same problem.
Welcome in robot
A robot
and
and the fruit. Alright. So that's easy. Okay, so the last problem was supposed to be difficult, a little simulation, and the others were not what? Oh, not hard. There are these different two sets of problems, and well, it means that you have more problems to look at when you study. But obviously, we had to have two different sets of tasks because you can't have people email at the start of the task, email their friends the solutions, and then have people, well, they could have done that during the test. Oh, there's lots of stuff to sort out. Practical tests are always difficult. You don't have to watch it. Why don't you come if you can watch it on YouTube? Say again?
Because I went to breakfast at 7 and I thought, it's the last day, we're doing the champagne again.
Today we're doing exciting stuff. So, these are Justin's marks, but the internet will never know. Oh no, wait, YouTube. That's his stuff. Say hi, Justin. Okie dokie. So, are we recording? Yes, we are. That's excellent. Today we're supposed to do, I've not yet added the project stuff. I've not yet fixed this one video that I have to remove that PVC penguin thing. But I was in the process of doing that when I had my breakfast at 5. And there's one more thing that I still have to do. Oh, the subtitles, English subtitles. Francois, wherever he is, rest in peace, has sent me all the texts, and I still need to upload them, but I haven't done that yet. The chances that I'll do them today or over the weekend are slim. Because, well, various issues. But they will be done, and I'm not going to promise by Monday, but that's what I'm aiming for. Today we're supposed to do standard audio because I really want to show you that stuff, but it's just a nice little program and it's not critical. What is critical for the project is that you learn about StdDraw. Because I can tell you that you can do the whole project with StdDraw. Is that how you, okay? So this is my implementation of the project. And if it starts up in a little while.
Can we kind of code it however we want, as long as it works?
Yes. As long as you satisfy all the requirements, you can do whatever you want. But you must satisfy the requirements. So you must be able to produce a text file, because in the demo, that is how the demo is going to check that you've implemented all the functionality correctly. And you must implement a user interface that satisfies the requirements, because they'll look at the user interface as well. They'll look at 3 things. One, they run a lot of tests using your text input and output to see that your functionality is correct, that it moves correctly and all that. Second, they're going to look at the user interface, because that's part of the project. And lastly, they are going to look at your code. Is it neat and tidy and readable? Can they, they look at 4 things. Can they see at a glance what's going on? Are there comments where there need to be comments? Do you indent properly? That kind of stuff. And the 4th thing they look at is if it's actually your own code. So they'll ask you to make a small change. To change the keys that you press, or the way that certain blocks move, or the output, the text output of the project, the program. So you can still cheat. I'm not saying you mustn't cheat. It's just that you have to copy the code and then study it well enough to understand it and be able to make a modification during the demo. I only have about 15 minutes, for the whole demo. So if you know that well that you can make the modification, I'm happy if you cheat. Having said that, you probably won't learn as much, and it won't be fun unless you do it yourself. But my real point is that this all that you see on the screen, this is all done with StdDraw. So for my implementation, I don't know what Reese is going to use, but for my implementation, I used StdDraw, and as you can see, say again?
You're pretty good at the game.
I know that one board very well because I've tested it over and over. Okay, so I've won, and that's all StdDraw. So we need to look at that today and to figure out how it works. Before I start, let's talk about the legal system. So you know that there's been this injunction or court case. I know nothing of the legal system, but once again, like the university's language policy has been in the courts and newspapers and all that. Are you all still happy with the scheme that we're running here? 1 week Afrikaans, 1 week English, website is only Afrikaans, textbook I cannot translate, tests on both languages. If you're unhappy, you must tell me. I'm prepared to make changes. We have to do it democratically. I can't have one person insist that I speak German, Justin. My German is just not good enough for teaching. Sie verstehen? Ja, danke. But if I can make a change, I will. I don't mind. I'm prepared to learn a new language if I have to. Right. So everybody's happy with language. Good. They can apparently fire me or take me to court if I don't speak the right language. StdDrawing. You have to learn about this. This is exciting stuff, and it's a pity we won't do the audio today, but we'll catch up at the start of next term. And one more thing. Okay. When we are done today, we've covered the first half of this course. You know, it's end of term. If you didn't know, next week is recess, and also Human Rights Day and Easter and that stuff. And so that means we are now at the level where we can start really being serious about programming. We've done all the constructs. We've done all the background stuff we need. We're going to do new stuff next term. But in essence, we can now write any program we need to, including the project. The whole of the project we can do using StdDrawing. So what is this all about? We want to draw pictures like this. And the authors of the textbook, Sedgwick and Wayne, they make this library available, which I'll still have to put up on the website, and I'll do that today. So you can download it over the weekend and start doing things. That is library called StdDraw. So there's the standard input, which is the pipe where all the input comes into the draw program, any program. You mustn't cough, please. There's been another comment on YouTube about coughing. Apparently, I sound like a high school guy with a microphone. Cough. No, you're coughing. Okay, let's not call it coughing. You mustn't noisy noise. Because it sounds so unprofessional, but until I spend like $10,000 and get fancy equipment, that's just life. Do you hear that, YouTube? I can't help it. So, standard input is a pipe that comes into any program. Standard output is another pipe that goes out of the program. And standard error, we don't really talk about that, but it's another pipe that you can send messages to. All programs are connected to these three pipes, and that's wonderful because we can use that for redirecting input. We can write the standard output to a file or read the standard input from a file, and we can connect the standard output of one program to the standard input of another program. And that's hunky-dory. Unfortunately, Unix programs or Windows programs, these programs, don't have a pipe called StdDrawing. So this library is, in some sense, faking it. And there are many ways to fake it. Reese has mentioned something obscure about doing it his own way, which means that he's going to use a different way of drawing on the screen. But StdDraw is really convenient because it has a lot of routines that we want that make it easy for us to make drawings. So the whole idea is that if you download this library and put it in your working directory where you're writing your programs, you don't have to do anything else. Reese has to do a lot of crap, but you don't have to do. With this little program, will work perfectly. So let's just see what it says. It's called public class triangle. Good, it's going to draw a triangle. Main, we know that. Then it says double T equals math.square root 3 divided by 2. Now that's simply the y coordinate. Oh no. Never mind, I wanted to do that. So this double T is simply the y-coordinate of this top point of the triangle. So you can see the bottom left point is 0, 0, and that's easy to write. And the rightmost point, bottom, is 1, 0. These are x and y coordinates. But the top point, because it's an equilateral triangle, it's at 1/2, and then the y-coordinate is fancy-schmancy, and I'm not going to show you the math, but trust me that if this is an equilateral triangle with these two bottom coordinates, then this is the top coordinate. Okay, fine. So now we have this y-coordinate, and we know the x-coordinate is 1/2, and then we can simply draw the 3 lines of the triangle. So we can do standard draw dot line, which will draw a line for us. X and y coordinate for the starting point, x and y coordinate for the destination point, the ending point. So this is from 0, 0 to 1, 0. That's the line. And our coordinate system, unless we explicitly change it, will always go 0 to 1 for x and 0 to 1 for y. Right, and I draw the other 2 lines from, well, I'm not going to go through this, but I draw the other 2 lines of the triangle, and just for luck, I put a dot in the middle of the triangle. So right in the middle, I put a little dot. And this will actually draw a triangle, this little program. Now, unfortunately, you're not going to see it, because the dot is so tiny, you probably can't see it from the back. I could have made it bigger, but this is the kind of dot this library draws. If you want to make it bigger, you have to draw a filled-in circle. And the line at the bottom is also invisible because it's right at the bottom of the screen. So I know that it just looks like TP, but trust me, it is a whole triangle. And if we were fancier, we could have put let's go not at 1, 0, but let's say at 0.9, 0.1, it would have looked like a triangle as well. So our very first little drawing. This is like the hello world of drawing. Fine. So what other routines can I use in StdDraw? There are many. There are tons of routines in this library that you can use, and I don't have a slide. I can't put them on a slide. You will have to go, we shall have to go to the author's website and look at their description, Princeton Intro Java. Let's just Google it. Oh, good. First hit is what I want. Let's see. So this is the website for the textbook. It's at Princeton University in the United States. Where is Princeton? Thank you. It's an Ivy League school, so it's somewhere on the East Coast, but I forget where it is. I don't care. We don't care. So if we go down to data, no, code, we can also go to the chapter. Oh, by the way, let's do that. So this stuff, first program, built-in data types, conditionals and loops, arrays, input and output. This is everything we've been doing this first term. So we've been doing the first chapter, and next term we'll do the second chapter that's got all this stuff. And if you go to any of these pages, let's just go to conditionals and loops. They have a little summary of the chapter, but I find it not even, it's better to read the textbook on paper or online, because this is not exactly the same. You probably will miss out on some stuff. You can't just read the webpage. I don't find that's enough. But then I do also read the webpage, because there are things on here, like links to programs, that is interesting. So they do all kinds of harmonic numbers. We don't even do that. All kinds of stuff. So this webpage is interesting. And most importantly, there's a Q&A that they kind of repeat from the book. And then right at the bottom, they have exercises. And often, they have solutions to these exercises. Maybe not on this page, but on the website. So you can do an exercise, and you can check that the solution is correct. Which is why I can't put any of these exercises into a tutorial. Firstly, I don't want you to just go to the website, copy the solution, and not learn anything from the TUT. But secondly, the the more exercises you have access to, the more you can learn. So I'm just assuming that you guys worked through these exercises, and at first it was slow and you were crying a lot, and your mum said, "What's wrong, Tony? What's wrong, Brooklyn? Why are you crying again?" But then later on you picked up speed, because the more you do, the easier they become. You can just like do 5 a day, 5 a night, whatever. Okie dokie. So these are the chapters. And in fact, I also have nice creative exercises, which is just like harder. They have tons of stuff. They've taken all the good exercises from the internet. Okay, all kinds of stuff. Anyways, back to where we want to go. If you go to the code tab, they have all these little programs, and these are in fact mostly solutions to exercises. So this is where you come to find the solutions. But they also have a link to standard input and output libraries, and then they have the StdDraw source code, which I will put on our website as well, but it is here if you want it immediately. Plus, the second link is the API, the Application Programming Interface, which explains to you how to use this library. It's a summary of everything inside the library. So if we click on StdDraw's description, they've got many little examples and explanations. They talk about how to use each of the routines. So there's a big, long description that almost covers, well, I think it does cover every single routine in the library. This initial description isn't always this long. Sometimes people are lazy and they just say, this is for drawing. But they've written almost a chapter here. And then the interesting part is down below, where they actually have a list of every single routine in the library. So let's have a look. We've just used this routine. So we used line. We said standard.draw.line, and we supplied an x and y coordinate for the starting point, and x and y coordinate for the ending point, the final point. And as they say here, it drew a line segment between these 2 points. And we also used StdDraw.point. There we go. So it draws a point centered at that place. As I said, this point is tiny. It's just one little pixel on the screen, and if you have a high resolution screen or projected like this, you can't really see it. So we probably have to use something called a filled circle. Do they have something like that? I don't know these routines. When I have to do something with StdDraw, I just come and look at this list. But all drawing routines, as Reese can testify if he's using something else, or any of you who's using a different API, they always have draw a circle, fill a circle, draw an ellipse, fill an ellipse, draw a rectangle, fill a rectangle, all that. And it's probably called fill circle. Oh, filled circle. There we go. So I could have used this routine to draw a bigger dot. Well, I didn't, because I'm lazy. Okay, right. So this is a list of all the routines. And while we're here, one routine that you'll need for the project, or a couple of routines, are these. Here is a routine called has next key type. So it checks if the user has pressed the key. And it's going to send back a Boolean. Never mind the static. It's going to send back a Boolean, true or false. If it's true, it means the user has typed something on the keyboard. And then you can read that key by calling this routine. No. Get. No. Or key type. No. Hang on. Just give me a second. Let's go to the top where they explain. Picture, set font, draw text, set X and Y scales, canvas size, pen color, all kinds of stuff. Where are the keys? Oh, here we go. Oh. So I can call these routines to ask if a key has been typed. I can also call them to get the key that's been typed. And Java will send back the key. Okay, right. So let's go back to our slides. So we've just drawn a triangle, and we know that we don't know what's inside StdDraw, but we know there's a long list that we can consult for example, for when doing the project. let's look at another little, let's combine what we did on Wednesday and today. So here's another little program. It's also graphical. It's called plot filter. Filter is a common word we use for those kinds of programs that read from the standard input and do something with the input. And often they write something to the standard output. So for example, sort, the Unix program sort, is a filter because it reads numbers from the standard input or lines, and it sorts them and writes them to the standard output. So it's a filter for the standard in and out. It performs some kind of transformation on input and output. This one is very nice. What it does is it says, start by reading a double from standard input. So standard in.read double reads a double that's coming in, and it stores that in xmin. So the minimum x coordinate. And then it does the same for x maximum and y minimum and y maximum. So it starts by reading 4 numbers from standard input, which tell us the x and the y minimum and maximum, the y minimum maximum. So I've got those numbers. Then it starts calling StdDraw. And what it does is it says set x scale. There's a typo. Next line should be y scale, but I think I fixed it on the web. Set x scale, which will recalibrate StdDraw so that the coordinate system is no longer from 0 to 1 for x, but from x min to x max. And the same for y. This should be set y scale from y min to y max. So if I now plot points, the bottom left-hand corner will be x min, y min, and the top right-hand corner will be x max, y max. This is my coordinate system. And now it carries on. It says, while standard in is not empty. So while there are still numbers coming in on standard input, read the next pair of numbers and put them in x and y. So 2 double coordinates that I'm storing in x and y from standard input. And then all it does is to plot that point on the screen. So it reads 4 numbers to tell me the coordinate system I'm using. And then it reads a lot of points until there are no more points, and makes a plot on the screen. And you think this is stupid and simple, but it's amazing. Okay, right. So I think it's called something, I called it something else. So let's have a little look at this file. This file starts with 4 numbers that are the x and the y min, and then it has a long list of coordinates. So at the moment it's in a file, but I'm going to use my less than operator on the command line to redirect this file to standard input. And I'm going to run Java plot filter and make this file its standard input. And it's going to go through this list and plot all of these points. How many points? Word count the lines. It's a 13,500 points. And these points are actually cities in the USA. So if I run Java plot filter and I redirect standard input to come from USA.text, let's hope this works. Can you see? Oh, you can see it. So I didn't have time to spend hours on harvesting the coordinates of all the cities or all the towns in South Africa, but I might do that if I'm really bored and have loads of free time. So, maybe next year. If you follow the course, we'll see it next year. But I think this is pretty impressive. We can draw things like this, which is interesting. I mean, think, for example, if I had find somewhere in the internet, let's say not even x and y coordinates, but GPS coordinates, so latitude and longitude. But we've already written a little program that can convert latitude and longitude to x and y coordinates. Do you remember? I can't remember when, but it was some time ago. Let's just see if I can find it. University has to crack down on these biker gangs with their 50cc hogs. Now we get it, you've got a bike. Okay, right. So we wrote a little program long ago that changes latitude and longitude to X and Y coordinates. So I don't even need to do it by hand. I can just find a list of GPS coordinates, it'll be fine. Okay, right, back to, where are we? Let's go back to here. Oddly, this thing is positioned at the bottom. And this is kind of like a defect of StdDraw in the sense that because it's not a square coordinate system, it put the picture at the bottom. The coordinates are specified, the x min and y x max, y min and y max didn't form a perfect square. So I may have to do a little work to fix that up, but it's fine for now. Okie dokie. So we can actually do, I think, amazing things with StdDraw. Yeah, that's just an illustration. Oh, this is another one. We have time, yes. So you can probably hardly see it, but I'll show you in a second. We can plot any function we want. But unfortunately, I mean, StdDraw can't do everything. You can't just give it a function like, let's say, sine, and ask it to plot the function. That's why we have jobs. We are programmers, and we can kind of implement that using more basic tools. So in this case, we use StdDraw.line, straight lines to draw these functions. But you don't stand. Oh, God, what's your name? Right? No, behind you. What? Christian. Oh. Don't do anything. What's in front? Ricardo. Ricardo, it's Italian name. Okay, you're closest. Just close the window if you can. Hang on. Close the window, Ricardo. Ricardo, close the window. There we go. No, that's fine. Back on the have to stay like that. That's amazing. I mean, just closing the window, pack the sound entirely. That is great. Now, we want to draw a curve, but you know that sine wave is not a smooth. Oh, it's smooth. It doesn't have these line segments. So we have to find a solution, and the solution is to say we're going to approximate it by using tiny, tiny, tiny little short lines to draw the smooth curve. So if I approximate it with only 20 lines, I'm going to start at this coordinate, which is something, and I'm going to divide my x range into 20 parts. I'm going to calculate the function value at the next step and plot the line to there. Calculate the function value at the next step and plot the line to there. So if I know that this x range is, let's say, 1, and I want to take 20 steps, then each step will have to be 0.05 apart. So we start at x, let's say this coordinate is 0, 0, I'm going to start at 0, 0. Then my next x coordinate will be 0.05. I plot the function value at that point, x coordinate. And now I've got this y coordinate, I can plot my line to there. And if I do that for big enough n, I can actually get a quite accurate approximation of my function. Now in this case, it's not sine, it's sine 4x plus sine 20x. But I don't really care what the function is. As long as Java can write it, we can put anything here. In fact, we'll play around with this soon. Basically what I do is, I say, oh, the mic batteries. Okay, fine. Okay, YouTube, don't panic. I'm changing the batteries. I don't know. I hope it's not one of you who complains about the coffee. I think it's someone in the Ukraine. I know where you are. Don't know why you're watching my video. I don't mind. Like me. Okay, hang on. Big one there. Okay, back online. Now, we were plotting the function. Oh, thank goodness. I almost thought I caught my student card in the drawer and it's locked. So in that case, I would be trapped. I'd have to take my pants. Oh, well, we know that. So we take any function we want, and we divide our x range into the little segments, 0.05 say. We have a for loop that goes over these segments, and for each segment, we plot the next y coordinate, so now we know the x and the y, and we draw a line from our previous coordinate to the next. So let's just see what it does here, what the code does. It says, oh, it's going to put all the y values in an array, but we don't have to do that, but let's do that. So that's my array where I store my y values. It's called A, it's a stupid name, but never mind. I've got a for loop that repeats n times, so it starts at 0. It repeats n plus 1 times. It starts at 0, where x is 0, and it goes up to and equal to n. So it goes right to the end, where x is equal to 1, say. And then it says that function value at point I, the I function value, is whatever my complex function is. And everywhere where I see x, I've just replaced it by I over n. When I is 0, this I over n will be 0 as well. And in the last iteration of the for loop, when I is equal to n, I over n will be 1. So I'm plotting the function in n steps, or n plus 1 steps perhaps, from 0 to 1. I'm putting all the y values in array A. So now I've got my y values, and then I set my scale, and I say standard draw a line from x is I, and the associated y coordinate is a of I, and the next one is I plus 1, and its y coordinate is a of I plus 1. Let's just say that again in case I made a mistake. So I'm drawing from AI to I plus 1, AI plus 1. Drawing the line segment for each of the coordinates I calculated. So I'll show you how it looks. I think it should be a little clearer on here. Let's see. Java, what is it called? Plot function. Yes, it is. Okay. Let's start with like only 6. So now it's going to be a really very rough approximation. Very rough approximation of a sine wave. Okay. 6 didn't work. Is my program broken? No. Okay. No. So 10 is looking better, and this is not a sine wave. Don't expect a sine wave. We can do that in a second. Let's go 20 as on the slide. Oh, okay. And let's go full out, 2,000. That's making an array with 2,000 doubles. It's dividing the range up into 2,000 little bits. For each bit, it's calculating the y coordinate, putting it inside that array, and then it has a for loop that draws a line from one coordinate to the next, one coordinate to the next, one coordinate to the next. And that's the function. What is the function? Let's just close that. The function is sine of 4x plus sine of 20x. Okay, let's change that. I want to see other functions. I love doing this. I can literally play with this thing for hours. So plot function, no, plot function.java. Okay, I don't want. Let's see what happens if I make the second sign a cosine, and I'm going to make it 19. So now I'm plotting the function y is sine of 4x plus cosine of 19x. Okay, I'm going to compile. Working, okay, right. And I'm just going to plot it for 2,000 because we know we need a high number to. How fast is it? Oh, it's not too slow. Oh, it's just about the same. Just for sanity, let's just check that a sine wave is actually plotted correctly. So sine of 0 is 0, it used to be when I was at school, and sine of 90 is 1. But we must remember that we're working in radians. So we can't talk about 90 degrees, we have to talk about pi over 2 radians. And then sine of 180 is 0 again, but that's sine of pi. And sine of 2 pi is got one big cycle. So if I just try to plot 0 to 1, I won't even get halfway up to the 90. Because pi over 2 is like 1.7 something, 72. So I can just plot from 0 to 1. I have to plot from 0 to 360, which is 2 pi, which is like 7. Okay. So instead of making my x range larger, I'm just going to put a factor in front of my x, just like they did. You'll see what I mean soon. Okay. I'm going to comment this out. And instead of plotting, never mind. Instead of plotting the sine of x, I'm just going to scale, I'm just going to put a factor in front so that I actually plot the sine of 7x. And that should give me just a little more than a full sine wave, up, down, up. Because 2 pi is 6.2837, no, not 7. Okay, let's see if I'm correct. If I'm not correct, it means my thinking is wrong. I have to fix it, which is a good thing. This is good exercise. Thinking is good. I did not expect that. I did not expect that. That's what's wrong.
You didn't use the Matplotlib.
Matplotlib. It doesn't matter. No, that's something else. Just ignore it. Oh man, what's going on? It doesn't look. It's not even curvy. What is going on here? What's your name? You're always in class. You listen to me on the YouTube.
No,
Listening to me. What is it? The answer is. What's going on? It's not even curvy. I need help, people. I need serious psychological help. Oh man, big mystery. Let's just go back to that stupid program. I never liked this program anyways. Oh. What am I plotting? I'm plotting 7 times x, and x is I over n. But 7 is an integer, I is an integer, so it's going to do 7 times I, and then I divide by n. And n is also an integer, so I'm doing integer division. I'm not getting a real numbers here. I'm getting, it's stepping. So when I is 0, 7 times 0 is 0, divided by n is 0. When I is 1, 7 times 1 is 7, but divided by n, which is 2000, is still 0. So I've made a big mistake. I shouldn't have said 7. I should have said 7.0. Now this will turn 7.0 times I is a double now, and when I divide by an integer, it'll do double division, and I'll get like 0.001 or whatever. So it's my integer division that caught me out. Okay, right, cool. I think that's the solution. Look, I didn't know it was going to do that. It's only when I saw the blocking function that I thought to myself, not going to Aussie accent. Oh, crikey. Okay, fine. So when I saw the blocking square, I thought to myself, crikey, right? What's going on? Oh, bollocks. So that's back to English. Okay. I'm not going to get to do my North of England accent. You guys are slowing me down. You're like a weight around my neck. Okay. So I may still be wrong, but I'm not. Okay. That's exactly what I wanted it to do. But I may still have been wrong because that's how you code. You do something and the computer does what you told it to, but it's not what you expected. And you have to formulate some kind of hypothesis about where did I go wrong. So you think to yourself and you try to fix it, and then, well, maybe you get it right and maybe you don't. I could still have been wrong here. In any case, let's get to my, okay, we're almost there. Right, so we're going to play a little game. It's called the chaos game. We have a triangle, equilateral, just like in the first diagram, the first slide. I'm going to start at point 0, 0. The triangle goes to 1, 0, and the funny coordinate, which is the top of the triangle. And in each step, I'm going to pick any of the vertices. So either red or blue or the green vertex. One of the three. And then I'm going to move from our current point, which is point 0, to halfway in between the chosen vertex and my current vertex. Now, if I chose red as my random vertex, I would have stayed here. Because halfway between this point and the red vertex is this point. But had I chosen blue as this, as in this illustration, I move halfway to the blue vertex. So now I'm at point 1. And then I choose another random vertex, let's say blue again, and I move halfway there, and I'm at point 2. And then I choose, let's say the green vertex, I move to 3. I choose the red vertex, I move to 4. Blue, move to 5. Green, move to 6. It's a funny game, but the question is, what is going to appear on the screen? What is going to appear on the screen? So here's my code. It's called chaos. T is an integer I get from the command line to tell how many times do I have to do this kind of simulation. It's not exactly a simulation, but kind of. And then I've got 2 arrows. One is called CX, which stores the x coordinates of my 3 points. So CX0, oh, the braces are missing. That's just a display mistake. I think I fixed that as well, but clearly I didn't on the slide. So just imagine there are braces around these arrays. Sorry that I'm missing. So CX0 is 0.000, and that's the x coordinate of my red point. CX of 1 is 1.0000, and that's the x coordinate of my blue point. And CX of 2 is 0.500, that's the x coordinate of my top blue point. Sorry, the second one is green, and the last one is the blue point at the top of the triangle. And the same for CY. It's simply the x coordinate. So red is at 0, 0, green is at 1, 0, and blue is at 0.5 and 0.866. That's a funny value. Right, so I've got my 3 coordinates for my 3 points. And then I say, make 2 more variables, doubles, x and y, and they start at 0, 0, 0.0. That's my current coordinates. I've got a for loop, I'll execute t times, and each time I pick a random point, so I call math.random, multiply by 3, round down to an integer, so it's 0, 1, or 2. So it's one of the 3 vertices, 0, 1, 2. And then I calculate the average of my current coordinate, x, and the coordinate of that point, and the average of my current y, and the y coordinate of that point that I've chosen, CYR, CX. And this is just average calculation, so I'm moving halfway, and I plot that point. Another question is, what is going to appear on the screen? Any guesses by people who don't know the answer? Wild guesses? Is it a face? Or the Mona Lisa? It may be. Java. Okay. Let's do 10,000 points, because I'm really small. Oh, I have to start. So this is called the Sierpinski triangle. It's a triangle with a finite area. So if you count area, if you did this mathematically to infinity, and you counted the area of all the black dots, it would be finite. So it's something like 2.3 square units. But if you count the circumference of this triangle, so you count this distance, that distance, that distance, that is infinite. So it's a funny shape with an infinite circumference and a finite area. And there are many of these things, they're called fractals. I'm going to stop in a few seconds, but I just want to show you the colored version because it's so much nicer. If I choose a blue point and I plot that point in blue, then I actually get a picture like this. Which is okay, which is nice. Okay. So I'm going to stop, and next term we'll simply have to carry on. If you want to work on StdDraw during the recess on your project, just go to that website, look at YouTube for the URL, go to that website and look at the API for StdDraw. Right. Okay, thank you so much.